All right, in this video, we are going to start simplifying expressions using exponent rules. And so this is day one. We're just going to explore a couple of the rules, and then on day two, we'll explore the rest of them. And so starting with the warm-up, we are going to simplify expressions with rational exponents. And so whenever you see a 1/2 power, that is the exact same thing as a square root. And then we know square root of 49 is just 7. 49 is a perfect square. 7 squared gives me 49, and so that is our simplified expression. Here, 125 to the 1/2 power is the same thing as square root of 125. 125 is not a perfect square, and so if we make a factor tree, 125 is 5 times 25, and then 25 is 5 times 5. Okay, and so looking at our primes here, we have a pair of 5s. And so we write 1 5 outside the radical, meaning it was a perfect square. And then we have 1 5 left behind. And so whatever is left behind stays under the radical. And so our simplified expression is 5 square roots of 5. Remember, it's not simplified until you get all perfect square factors out of the radical. Okay, for this next one, it says 16 to the 3/2 power. Okay, and so you could view this 1/2 power as the square root, but we still have this 3 on top. Okay, and so taking the 1/2 power is the same as square root. Square root of 16 is 4, but we still have this power of 3. And so now we just need to figure out 4 to the power of 3, which is 64. All right, so a couple rules of exponents is anything raised to the 0 power is 1. It doesn't matter how ugly it is, doesn't matter if there's a variable or not. If you raise it to a 0 power, it turns to 1. And so, for example, if I type just a big number in parentheses and then raise that to the 0 power, it gives me 1. Okay, so whether there's variables, whether there's numbers, anything raised to the 0 power is always 1. The other rule we're going to talk about right now is a negative exponent. If you see something raised to a negative exponent, it kind of means it's on the wrong side of a fraction bar. So you could view this as a fraction over 1, and then it means you should really have a to the positive n power. Okay, here we have a to the negative n on bottom, and so we should really have it on top with a positive power. So I treat a exponent as kind of like the attitude. He has a negative attitude because he doesn't like where he lives. And so if you change where he lives, he now has a positive attitude. He likes where he lives. So anytime you see a negative exponent, just kind of think they're not happy where they are. And so if they're on top, they want to live on bottom. If they're on bottom, they want to live on top. Okay, and so you can kind of just think about moving them to a better location. Okay, and so let's do some examples with that. So here it says 8 to the negative 2. And so that means I should really have that 8 to a positive 2 below the fraction bar. And we know 8 squared is 64. So 8 to the negative 2 power is the same as 1/64. Okay, here it says 64 to the negative 1/2 power. So that's really 1 over 64 to the positive 1/2 power. Okay, a 1/2 power we talked about is the same thing as a square root. And square root of 64 is just 8. So that whole thing simplifies to 1/8. Okay, and so you can even verify that in the calculator. 64 raised to the negative 1/2 power is 0.125. In fraction form, it is 1/8. Okay, so now let's start looking at a 0 exponent. Square root of 125 raised to the 0 power is just 1. Anything raised to the 0 power is 1. You saw that when I typed that ugly number earlier, but I can even type the square root of 125 raised to the 0 power is 1. Okay, here we're going to start working with variables. I see a negative exponent. That means he doesn't like where he lives. So he wants to move to the top of the fraction to join the x squared. And since there's nothing left on bottom, we don't need a fraction bar. We don't have to write a 1 on bottom. We can leave it as just x squared times y to the 7th. Okay, here I have a really ugly expression raised to the 0 power. That whole thing is a 1. And then we have this 3 outside. The 0 does not apply to the 3, and so he's still there. And so 3 times 1 would simplify to a 3. Okay, this next example, we have this expression raised to the 0 power. So that whole thing turns into a 1. We still have that square root sign. We still have the 25. 25 times 1 is just 25. Square root of 25 is just 5. Okay, next rule we want to talk about is the product of powers. And so to use a more concrete example, if I had a cubed times a squared, if I were to expand that out, a cubed is 3 a's being multiplied. A times a times a. A squared is another 2 copies of a. So I have a total of 5 copies of a really being multiplied here. And so anytime you're multiplying 2 powers with the same base, you add their exponents together. Okay, think of expanding it out. So a to the m, a to the n would be a to the m plus n. Okay, and so here y squared times y third, that would be 2 y's times another 3 copies of y. And you can put dots between them all, and so that would be y to the 5th. And so now we know that rule, we can just immediately start applying it. It's tempting to multiply the 2 and the 3, but you want to add the exponents. Okay, here we have some multiplication, and so sometimes we represent multiplication with parentheses, sometimes we represent it with a dot, sometimes they don't put either of those signs. So if you want to rewrite it, all of these are just being multiplied together. Okay, same thing. And you can even put them in any order. So if you want to put the k's together and then the j at the end, that would work too. And so the only thing we can combine are the k's. And so I have 8 k's times another 13 copies of k. That would be 21 copies of k's on the board. And then we still have those 7 j's being multiplied. Okay, and so here we have some coefficients. These big numbers, they are not bases. They don't have exponents on them. They are just coefficients, just numbers. And so if you want, you can add a multiplication dot. All of this is being multiplied. And so we can put the numbers together, and then we can put the n's at the end. Nothing stays attached to anything. They're all being multiplied. And so whenever you see these big numbers, these coefficients, you multiply them. Don't start adding, because it says 2 times 3. We know that's 6. The numbers you add are the exponents, okay, the little numbers. And so multiply the coefficients, add the exponents. And so this would be 6n to the 9th. And so something you will hear me say a lot is multiply your big numbers, which are the coefficients, add the little numbers, the exponents. Multiply coefficients, and coefficients are big numbers without exponents. And then you add exponents, the little numbers. Okay, and so on this next one, I have 2 coefficients here, -5 and -6. So if you want, go ahead and write those out front, -5, and we're going to multiply those. And then we have a to the 6th and a to the 12th. And so we're going to add the 6 and the 12. And then we have b to the 11th and b, which is technically to the 1st, if you want to write in that 1. So we're going to have b to the 11 plus 1. And then we have a c that doesn't have anything with it. Okay, so to simplify this, I would get positive 30, a to the 18th, b to the 12th, and then c. That would be my final answer. Multiply big numbers, add the little numbers. Okay, on this next page, I have a negative exponent, and so we could rewrite that like we did in the previous examples, or just using our rule, we know we would add the little numbers, okay? So this time my base is 2, it's a number, but just like if it was A, those aren't big numbers, those aren't coefficients, so you're not gonna get 4, you're not gonna multiply those are bases. So you could treat that like an A to the 5th, A to the -3 would give me A to the 5 plus -3. Here, 2 is a base, not a coefficient. Base, not a coefficient. So you don't multiply bases together. You keep the base and then add the exponents. And so 5 plus -3 is the same as 5 minus 3. So 2, and we know 2 squared is 4, so anytime you're working with a base that's a number, you can simplify all the way to what that number is. Okay, here we're working with x's, and so here I am going to rewrite it because we don't know the property for division yet, but I see a negative exponent, which means he's not happy where he lives. And so he's gonna join x squared on top, and now he's positive, he likes where he lives. And then using our rule, we would add the 2 and the 7 to get 9. Okay, here we have an application problem. It says the length of a rectangle is represented by 3x squared y. The width of the same rectangle is represented by 2xy. What is the area? Okay, and so we know area is length times width, which in this case is 3x squared y times 2xy. Okay, and so we're back to multiplying our big numbers, okay? This 3 and the 2, there's no exponents, so those are coefficients. We can put them out front. And then we have x squared and x to the invisible first power. So we're gonna have the 2 plus the 1. And then we have a y to the first, y to the first. And so we're gonna have a y to the 1 plus 1. So this simplifies to 6x to the third power, y to the second power. Okay, next we have a bunch of c's being multiplied together. And so we're going to add all these exponents. Okay, so we have c, 4 plus 5 plus 1/2 plus 1. 4 plus 5 is 9, plus that 1 is 10, plus the 1/2. To figure out 10 plus 1/2, we need a common denominator. And so go ahead and write that whole number over 1. We would multiply top and bottom by 2 to get that common denominator, which would give me 20 over 2 plus 1 over 2, which is 21 over 2. And so our final answer is 21 over 2. You always leave your answer with a simplified fraction as your exponent, not a mixed number, not a decimal. Simplified fractions only, no decimals. And no mixed numbers. Okay, and so now we can talk about what to do if we divide. When we multiplied, we were gaining copies. We had 3 plus another 2, which gave us 5. When we're dividing, we're going to be losing copies, okay? And so another concrete example, let's do a to the 5th divided by a to the 3rd. That would be 5 a's being multiplied on top, divided by 3 copies being multiplied on bottom. So multiplication and division cancel. Remember, this means division. And so A. And so that leaves us with 2 copies of A, which is the same as A squared. So now when you see 2 exponents being divided, you're going to subtract these exponents. So this would be a to the m minus n, and you can think of them canceling. You're losing copies. Okay, and so here, if we were to expand it out, I would have 4 copies of x divided by 2 copies of x, and then 2 of them would cancel, leaving me with 2 of them left. Okay, so don't divide these, you would subtract them. Okay, and so for this next one, using my rule of subtraction, I would have 3 minus the 2 for the x's. I would have 5 minus the 2 for the y's, which simplifies x to the 1, y to the 3rd, and we don't usually write the 1. Okay, for this next one, it's the same idea as the previous one. I have coefficients again. So that says 8 divided by 2. Don't start subtracting that. 8 divided by 2 is still 4. Okay, and then this 5, those are exponents, so you are going to subtract those. Okay, and same with the n's. You're going to subtract the exponents. So in this case, you divide coefficients, which are the big numbers, not bases. Make sure they don't have exponents on them. And then you are going to subtract the exponents, the little numbers. Okay, and so when we simplify this, we get 4m to the negative 3rd n to the negative 3rd. So because I am left with some negative exponents, that means these are not written in the correct place. Okay, and so the 4 would stay. You don't get to move coefficients. You only get to move negative exponents. So m to the positive 3rd, n to the positive 3rd. Both of those should have been written on bottom. Okay, and so if you think of the canceling, with the m's, I had 5 on top being multiplied, and I had 8 on bottom. So there's the 5, and then I had 3 extra on bottom. Okay, and so 5 of them canceled, leaving me with 3 on bottom. And so that's why I got that negative exponent when I subtracted. You're always subtracting the bottom from the top, bottom from the top. And when you write them, if you get a negative exponent, that tells you you should have written them on bottom. That means you had more copies on bottom. Okay, here we've got some coefficients. 25 divided by 5 is 5. And then for the exponents, I have x to the 4th over x to the 1. That's going to give me x to the 4 minus 1. For the y's, I have 11 minus the 5, top minus bottom. And for the z's, I have z to the 8 minus 1. Okay, so just kind of collecting the like terms. And then when we simplify, you get 5x to the 3rd, y to the 6th, z to the 7th, all positive exponents. So they all ended up in the right place. We had more on top than bottom. Okay, and then for this application problem, this time they're giving me the area of the rectangle and the length. We need to find the width. Okay, so the width, we would take the area and divide out the length, and vice versa. If we needed the length, we would divide the area by the width. And so the area is given by the 56x to the 10th, y to the 11th. And then the width is given by 8x to the 3rd, y to the 4th. Okay, and so same drill. We're going to divide the coefficients. 56 divided by 8 is 7. And then we're going to subtract the little numbers. So 10 minus 3 for the x, 11 minus 4 for the y. So that gives me 7x to the 7th, y to the 7th. Okay, and then this last one's the hardest it could get. Okay, and so start by simplifying your coefficient. If you're starting with one fraction bar, you should end with just one fraction bar. Okay, and so 16 over 6. Both of those can be divided by 2, and so that simplifies to 8 over 3. Okay, and then now looking at the x's. I have x to the 3/2 over x to the 4th. That means I'm going to do 3/2 minus 4. And so to figure out the 3/2 minus 4, we need a common denominator. So we're going to multiply top and bottom of the second fraction by 2, which would then give me 3/2 minus 8/2, which is -5/2. Okay, and so when you do this rule, it assumes you're writing it on top. So because we got -5/2, that means it should have been written on bottom. And so we're going to write x to the 5/2 on bottom. X to the 5/2 goes on bottom. That's what that negative tells me. Okay. Okay, and then for the y, we have y to the 1. You can write in that invisible 1. And then over 5 to the 3rd. So we're going to subtract the 5/3. Okay, and so to figure out 1 minus 5/3, 1 is the same thing as 1 over 1. We need to multiply top and bottom by 3. Okay, and so that would give me 3 over 3 minus 5 over 3, which is -2 over 3, which means y to the 2/3 should be on bottom. Okay, so y to the -2/3 means y to the +2/3 goes on bottom. When you do this rule of subtraction, it assumes you're writing it on top. So if you see that negative exponent, that means it goes on bottom. And so your final simplified answer would have only an 8 on top. The 3 would be on bottom, the x to the 5/2 would be on bottom, and the y to the 2/3. You only get this one big fraction bar. What you don't want to do is put like an 8/3 on top of these variables. You don't want fractions within fractions. You can have fractions in the exponents, but you cannot have fractions for your coefficients. Okay, one fraction bar.